Hi everyone. Today let's talk about a new data structure called BloomFilter. This is one of the popular and heavily used data structure across databases and cache systems. And of course, it's also heavily used in various distributed systems. Let's see its purpose and how it works internally. Yeah, let's go. So let's talk about its use cases, where we can use Bloom filter. So let's we might have encountered this use case very often, like when we trying to sign up account across websites. Usually we provide our own username, and website instantly will tell us whether that particular username is already taken or not. This is one use case where Bloom filter could fit in. And another use case is like, for example, uh, you know, let's talk about web crawler. So web crawler goes from one website to another website, or one web page to another web page, and during that phase, it encounters the new URLs. And one of the key point or key important thing about web crawler is that you should avoid visiting the same URLs again and again. So it has to track already visited URL somewhere, and when it encounters a new URL, it has to verify that that URL, that particular URL has been already visited or not. If it has been already visited, it can skip it, move on to next one. If it's not visited, it can go ahead and visit that particular URL. So this is the another use case where Bloom filter could fit in and serve the purpose very well. Let's see uh, what is a Bloom filter exactly. So as per the textbook definition, it's a probabilistic data structure. Let's talk about what is probabilistic here, but it's nothing but a data structure, something like hash set, you can imagine. So it could capture the data, and when we want to verify that particular element is present in the data structure or not, it could gives back yes or no binary answer to us. It won't gives back the original element or data, but it will tell us whether that particular element is already present in it or not. That's how it could say. So you can think you might get confused by thinking that why we need this data structure. We already have hash set for this purpose. So hash set also takes in new data, and when we want to verify whether that particular element is present or not, it could do the exactly same thing, right? So uh, why we need Bloom filter? So the main advantage of using Bloom filter is that Bloom filter takes less space and less time uh, to answer the questions. So when I said less space, it doesn't store the raw data or original data as it is, but it uses something called bit array internally, and it sets the corresponding bits to 1, indicating that that particular element is present. So that's the crux of the Bloom filter, and that's how it is, going to save a lot on space. Instead of storing the original data, it sets the corresponding bits to 1 in a bit array and use those indication to determine whether that particular element is already present in it or not. And time, again, it uses the hash functions and bit array heavily. So those are known for constant lookups and the constant time complexities. So that's how it's going. That's how it achieves very less time to answer the user queries. So as we discussed, we could get back either yes or no. No means that element is not present in the data structure. Yes means that element probably might present, probably present in the data structure. So when I said that's why the I mean that's why when it says no, it's 100% accurate. If it says yes, uh, based on the use case, we might need another check to verify if that particular element is really present in the data structure. Some kind of additional check is needed. So that's the trade-off we need to accept to gain advantage of space and time. So we are compromising little on the accuracy here. And again, this accuracy and part is again compromisable or configurable again. So if you want more accuracy, again, you are going to lose on space and time advantages. So we need to balance that one based on the use case to use case. So let's see how it works internally. So as I mentioned already, BloomFilter uses the bit array and hash functions to achieve this functionality. So a bit array, is going to have either 0 or 1 as particular index, right? So when we are trying to insert new data, so the data item will be passed on to the k hash functions, and each hash function will compute the hash, and it will map the hash to one of the index in the bit array, and at that index it sets the uh, value to 1, indicating that that element is present as per that particular hash function. So on lookup time, the, the lookup key will be passed on to the those same k hashes, and again they'll check, compute the hash, and they'll determine the index, and they'll go and check the front value of that index. If the value is 1, it means that as per that hash function, that element is present. And so, so the Bloom filter checks across all these k-hash functions. If all k-hashes say that, or comes back with 1, it means that the element is might present. Again, might present. That's a very important thing to understand. It's not 100% accurate. But but if one of the hash functions says comes back with 0, it means that the element is not present, and that is 100% accurate. So no is 100% accurate. S is probably accurate. So that's how it works. So it uses a combination of bit array and hash functions, and it computes the hashes index and go set those indexes to 1, and during lookup time check those indexes to determine whether that corresponding element is already seen or not. So that's how it works. Yeah, let's learn about more about this Bloom filter in the upcoming videos. Stay tuned. Thank you.